Welcome to the tutorial over 4-5, Completing the Square. Your new vocabulary is completing the square. We will get to this vocabulary later in the video. Example number 1, we're going to solve x squared plus 14x plus 49 equals 64 by using the square root property. First, we should be able to recognize that 49 is a perfect square, and so is x squared. And we know that the square root of 49 is 7, and if we double 7, we get 14. So this actually factors very nicely to get x plus 7 squared is equal to 64. So we already know how to factor this, but now we're going to take the square root of each side. And what happens when we do that is that the square root and the square will cancel out. So we are left with x plus 7 is equal to, and we know that the square root of 64, and don't forget we have to put our plus or minus, okay? So we get plus or minus 8 because 64 is a perfect square as well. Now we have to set up two different equations since we do have a plus or a minus. We get x plus 7 equals negative 8, and then we get x plus 7 is equal to positive 8. And we're going to solve for x in both situations. Here we're going to subtract 7 from both sides, and we get x equals negative 15. And over here we're going to subtract 7 from both sides, and we get x is equal to 1. So our two answers are x equals negative 15 and 1. And we can actually write this as a solution set with our brackets of negative 15 and 1. Now, you always want to make sure that you plug back in and make sure you get your correct answer. So, first I'm going to use negative 15. So, negative 15 squared plus 14 times negative 15 plus 49, we want to equal 64. When we plug and chug, we do get 225 minus 210 plus 49 equals 64. 225 minus 210 is 15, so we have 15 plus 49. Does that equal 64? And the answer is yes, 64 is equal to 64. So we know that negative 15 for sure is one of my answers. Now I'm going to do the exact same thing and plug in negative 1. So we get, let's see, 1 squared plus 14 times 1 plus 49. Does that equal 64? We get 1 squared is 1, plus 14 times 1 is 14, plus 49. Does that equal 64? 1 plus 14 is 15 plus 49, and 15 plus 49 is 64. So 64 is actually equal to 64. So we know that these are both my solutions. So my solution set is x equals negative 15 and 1 with our curly brackets. Example number 2, we're going to use the square root method again. We're going to solve x squared minus 4x plus 4 equals 13 by using the square root property. So again, we should easily be able to factor this. We know that x squared is a perfect square, 4 is a perfect square. We're going to take x, and we know that the square root of 4 is 2, and we know that we're going to have this squared, and we have to look here and we see, oh, it's a negative in the middle, so this needs to be x minus 2 squared, and it's going to be equal to 13. Now, using the square root property, I can square root both sides, and I get x minus 2 is equal to plus or minus the square root of 13. Now, we can't really take the square root of 13, that's simplified, so we're just going to move 2 to the other side and get x equals 2 plus or minus the square root of 13. So, our answer is x equals 2 plus the square root of 13 or 2 minus the square root of 13. And of course, plug it back into your equation, make sure you get the right answer. Now we're going to move to completing the square. To complete the square for any quadratic expression in the form of x squared plus bx, follow the steps below. Step number 1, we're going to find half of b, the coefficient x. Step number 2, square the result in step 1. And then we're going to add the result to step 2 to x squared plus bx. So we're going to find the value of c that makes x squared plus 12x plus c a perfect square, and then we're going to write the trinomial as a perfect square. And this actually needs to be x squared. So x squared plus 12x plus c. We're going to ignore c for now. We know that a is equal to 1, b is 12, and we don't know what c is yet. Now, according to the perfect square, I'm going to take 12, and I'm going to divide it by 2, and I'm going to get 6. Alright, so now what I need to do is I need to take my answer and square it to get 36. So that means c needs to equal 36 in order to make this a perfect square. Now, to actually write this as the trinomial as a perfect square, we're going to put our x. We know that our value needs to be 6, and we're squaring it, and then we actually need to look at our signs. We said that we have both positive signs, so that means this needs to be a positive. And that's how you write the trinomial as a perfect square. Example 4, we're going to solve x squared plus 4x minus 12 by completing the square. Alright, so what I'm going to do is I'm going to write x squared plus 4x plus blank minus 12 minus blank equals 0. Now, the reason why I'm doing this is anytime you add something, you have to subtract it right back off. Okay? So we're going to complete the square here. We're going to take 4 divided by 2, and we get 2. Now, in order to complete the square, we have to take that result and square it to get 4. Now, I'm going to add 4, but since I added 4 to one side, I now have to subtract it back off, so that way I don't end up adding extra, because that would change the equation. I am now going to factor this and make it a square, perfect square. We get x and 2 squared, and let's look at our signs. We see that we have our positives, so that needs to be a positive on the inside. Now we have negative 12 minus 4, which is negative 16, is equal to 0. Now, in order to actually solve this, we can move the 16 to the other side, and we get x plus 2 squared is equal to 16. Now we can use the square root property to figure out what x needs to be. If we square root both sides, we get x plus 2 equals plus or minus the square root of 16. 16 is a perfect square. The square root of 16 is 4. So we get x plus 2 is equal to plus or minus 4. Now we're going to take x plus 2 equals 4 and x plus 2 equals negative 4 and solve for x in both cases. If I subtract 2 on the first one from both sides, I get x equals 2. And on the second one, I can subtract 2 and I get x equals negative 6. And those would be my two answers, and that's how you solve by completing the square. Alright, so example 5, we're going to take 3x squared minus 2x minus 1 equals 0 and complete the square. Well, the first thing we notice is that x squared does not have a 1 in front of it. We actually have a 3. So the first thing we have to do is actually divide everything by 3 before we are allowed to complete the square. So we're going to get x squared minus 2/3 x minus 1/3 equals 0. The next thing we want to do is add 1/3 to both sides. So we get x squared minus 2/3 x plus blank equals 1/3 plus blank, because now we're going to complete the square. So we're going to take this middle term and we're going to divide it by 2. So negative 2/3 divided by 2. And we take that result and square it, we get 1/9. So we're going to take 1/9 and we're going to add it to each side, so that way it technically cancels. Now we can actually factor, and we get x, and we know that 1/3 goes here because that's how we got 1/9 is 1/3 times 1/3 is 1/9. We're squaring it, and then we need to look at our signs. Is it going to be positive or negative? Well, notice we have a negative 2/3 here, so that means this needs to be negative, and that equals 4/9. And if you plug this into your calculator, you get 1/3 plus 1/9 is 4/9. And I'm going to erase all this so that way we have enough room. Next thing we're going to do is we're going to take the square root of both sides. We get x minus 1/3 is equal to plus or minus the square root of 4/9. Now, we can actually take this and take the square root of 4 over the square root of 9, which is actually equal to 2/3. So we get x minus 1/3 is equal to plus or minus 2/3. Now, let's set that up into two equations. X minus 1/3 is equal to positive 2/3, and x minus 1/3 is equal to negative 2/3. We're going to solve for x in both cases. We're going to add 1/3 to each side. And here we get x is equal to 1. And if we add 1/3 over here, we get x is equal to negative 1/3. So my two answers for this are x equals 1 and negative 1/3. For our last example, we are going to solve an equation with imaginary solutions this time. We're going to solve x squared plus 4x plus 11 equals 0 by completing the square. First thing we want to do is move the 11 to the other side. To get x squared plus 4x, we're going to leave a blank equals negative 11 plus blank. Now, to complete the square, we're going to take this middle term, divide it by 2, take the result, and square it to get 4. And that tells me what I need to add on both sides. Here we're going to get x plus 2, because that's what you get when you factor this, is equal to negative 6. Next step, we're going to square root both sides. To get x plus 2 is equal to plus or minus the square root of negative 6. Now, in the last video, we know that when we take the square root of a negative number, we can take that negative out by making it an I. So we get x plus 2 is equal to plus I times the square root of 6, and we have x plus 2 is equal to minus I times the square root of 6. If we subtract 2 to both sides, we end up getting the answer x equals negative 2 plus I square roots of 6, and we get x is equal to negative 2 minus I square roots of 6. And in this case, those are your two answers. Thanks for watching.